Hello again, everyone, and welcome to this webinar, Getting Across Spatial. I'm Claire, and I've been at the data school for a couple of months, and I'm just going to be talking you through spatial data and utilising the spatial tools in Alteryx. Again, there's a link to all the materials on this slide, and we can also use the link that's in the chat as well. So if you haven't already, I would recommend downloading these. Just so if you want to follow along with the exercises, then you can. So if you go on the chat section, then there should be a link there, but I'm going to use the one on this slide here. So this is the folder, this is how it should come up. And if you want to download anything, then just hit the download button here. And you should get a zip folder of all the information that you need. So I'm going to open this and extract all. And if you click on the folder webinar data, then you should get through to everything that we need for today. So it's a good idea to keep this folder up just so it's easily accessible. Great. So let's get started. Also, if you have any questions, please do add them to the chat, and we're going to try and answer them as we go along. So today, we're just trying to nail the basic principles of spatial data and look at a few tools that we can use in Alteryx to explore. We're also going to have a bit of fun building some maps as well. So first, we're going to have an introduction to the basics of spatial data and look at some of the applications. Then we're going to have a look at the key tools in Alteryx and where to find them. And then we're going to move on to working on some practical examples with the data that you've downloaded. So what is spatial data and why do we need it? In essence, it's information about the locations and geographic features and relationships between these. Everything that happens somewhere. So spatial data is vital to pinpoint places, journeys, and even trends on maps. So why do we care? We all use spatial data every day, I'm sure, from finding the nearest restaurants to finding the fastest way to work and mapping our workouts. And apps like Citymapper, Uber, and Google Maps bring powerful spatial data to the palm of our hand. Spatial data also has huge implications for businesses and can help them make better and more productive decisions, such as where can we open the most profitable shops, or how can we transport our goods in the quickest, fastest, cheapest way. Also where we can build infrastructure. So let's move on to the fundamentals of spatial data. What makes up spatial data? At its heart, spatial data is made up essentially of points, lines, and polygons. And we'll sort of be using those terms interchangeably. Boundaries and polygons. Points could be latitude and longitude coordinates, an address, a postcode, or the name of a restaurant. On the slide, I've marked up the address of the information lab, 25 Watling Street, as a point on this map. But there's also a variety of other points, including Domino's Pizza, Virgin Active, or Boots. So those are points. Now, if we build two or more points together, then we'll get a line. Here I've marked the line between the information lab address, 25 Watling Street, and Bank Station. Now this line will hold information about the distance between these two places and things like that. build enough points and lines together, you'll get the boundaries of an area, or as Alteryx calls this, a polygon. Here I've marked the boundaries of the City of London. This polygon holds a wealth of information about this area of London. For example, how many stations there are, the square mileage of this area, what are the best restaurants, how many bakeries there are, etc. So those are our main spatial elements. And the benefit of Alteryx for this is that it can easily use its inbuilt tools to turn traditional data types into these spatial elements. These tools can be found in their own spatial toolbar. And on this slide, I've included an image of where they live. So yeah, it's just the green little blob that says spatial next to it, and that's where they're all hiding. So hopefully you will have that. If not, we can add these tools by clicking the white plus sign at the far right-hand side of our toolbar. Or we can search for any of the tools we're going to need in the search bar above. So just a brief overview of some of the tools that we'll be using today. I've grouped these into two main categories. The first category is creating spatial data, so making spatial data out of more traditional data types. So we're going to be using the Create Points tool, and this converts latitude and longitude coordinates into points on a map. We're also going to be using the Trade Area tool, which, as it suggests, creates a trade area around a specific point. We're also going to be using other tools that establish spatial relationships. And here we're going to be using tools called Find Nearest, Distance, and Spatial Match. So a great use case of spatial data is the Met Police. And by the way, the police have a lot of data sets available just online for public use. And these are big, great data sets to use if you ever want anything to play around with, or try out Alteryx or data visualization. So as we can see here, they've used Tableau to create this dashboard, which represents crime distribution within London. The map here shows crimes per borough, and we've got also more information about what type of crimes are happening most often. Now I want to recreate something like this map within Alteryx. It will be a more basic version, but it should tell us the boundaries of each shape, and in our table, it should also tell us how many crimes happen in each borough. So if we open Alteryx and open our folder of data, then we can begin. So I want to open the crime folder here. And then I'm going to use this data set here called Crime Data October 2019. And I'm going to pull that onto the canvas. So let's open the folder again. And I'm going to be using a shapefile of the London boroughs to give me the boundaries of each borough. Now, a shapefile, we're going to be using this one with the extension .shp. And basically this contains the polygons already. This contains the spatial data that we need already, so that we can map our crimes. So let's drag in the .shp file onto the canvas above. have our crime data. So and drag and drag. So let's put a browse tool on the end of our London Boroughs data. Let's go to the In-Out tab at the top and click and drag our browse tool next to our London Boroughs data. Now let's go over to Run on the right and press that. So great, here we go. This is what we wanted from our shapefile. As we can see, the structure of this gives a name of each borough, some code, the number of hectares, and crucially, this polygon here as the last column. This is the spatial element of our data. Lovely. So let's now put a browse tool onto the end of our crime data. So go back to the In-Out tab, click and drag a browse next to our crime data and drop it there. And let's go over and press Run. So our crime data consists of a crime ID number, the month, so the date of the crime, the longitude and latitude, location, some coding, the type of crime, and the outcome. But this does not contain any spatial points. So where we had our map on our configuration pane on the left before with the London Boroughs data, we do not have this time, as there is no spatial data included in this data set. If we want to map the crime points to the boroughs, then we'll need to create some spatial data here. Now we can do this easily with the Create Points tool. So let's go up to our Spatial tab at the top, click on that, and find the Create Points tool. Click and drag the Create Points tool to between the crime data and the browse and drop it there. Now, you'll see the configuration pane has changed because we usually need to configure this tool, but Alteryx has been able to pick up the latitude and longitude from the data already as those fields match. These are latitude and longitude floating points, so we don't need to change anything there. So let's go over to Run and let's run this workflow again. If we click on our Browse tool and go and click on Map at the side, then we can see that our spatial points are now rendered, and from the latitude and longitude, points have been created. If we also go down to our results pane and scroll through the data, then we can see that Alteryx has created this field called Centroid. This is the last field in our data set. And yeah, this is basically where our points information is. So now what I want to do is I want to map these points to each borough. Now I can do that with a spatial match tool. So that's on our spatial tab as well. So let's go back up to our spatial tab and take a spatial match tool, drag that down and put that in the middle of the canvas. Don't let this automatically connect to anything because I just want to explain the inputs and outputs. So as you'll notice, this tool actually has 2 inputs and 2 outputs. The only output that we're going to be focusing on today is the M output, which is the matched output. That is the only one we'll need to use. But we'll be using both the inputs. So there's a T input and a U input. So I like to think of it as the T input, which is our target, is our known, and the U input, which is our universe, is unknown. So what we know here is the London boroughs and the shapes of the London boroughs. And what we don't know is the points that fit within those. So what I want to do is I want to map our boroughs to our target and the points, whichever of those match to boroughs, to our universe. So let's go up to our London boroughs data, and there's a little green arrow that comes out of the side of the input tool. So if you click on the output anchor, click and drag this to the T input for the spatial match. Hold on, I've just heard that we're having some sound issues, so I'm just going to try a different set of headphones and I'll be back in a moment. Hold on. Hello. Hello everyone. I hope that you can hear this a bit better. I've just swapped out the headphones. So I'm just going to take some time to explain what we're doing with this tool again. So I'm going to delete this connection. So if I right click the string there that connects the two, and then click delete connection, then that will be deleted. So as I said before, we've got two inputs here. We've got the target and the universe. The target I like to think of as what is known. So in this case, what we know is the London boroughs and the shape of each borough. What we don't know is which crimes fit within those boroughs. So what I'm going to do is I'm going to connect our London boroughs data to the target input, because that is our target. That is what we know. So if you go to the green arrow on the right-hand side of our input data for the London boroughs, click and drag this to the T input of the spatial match tool. Perfect. Now we want to use our points for the universe input. So click on the output anchor of our create points tool. Click and drag up to our universe input and release. So let's click on the tool and just make sure it's configured properly. So the T input will be our polygon file, our polygon in our spatial object field. So if we go up here, yeah, that's our spatial object field. That is what we want to use as our target input. That's the only option we have. Now our U input, our universe input, is our centroid, the points that we created for the crimes data. And that's the only option we have here too. So that's great, that's all configured perfectly. I'm just going to use this opportunity to get rid of a couple of fields here that I don't need. So we don't need the GSS code, or the hectares, or the area, or the ONSNM, and I'll delete these couple too. We just need the name and the spatial object file field for these first few. So I'm going to click run to just make sure that error stops. And that's run fine. So if we click on our matched output, then it's actually, as we expected, mapping each prime to the borough that it falls within, which is perfect. That is what we want. Now I said what I wanted to do here was count up the number of primes that happen in each borough and find the borough with the most primes, like we had on that, that density map that we had on the Met Police dashboard. So I can do this using our summarize tool. So let's go up to the transform tab, click that, and click on our summarize tool. So I want to drag that next to our matched output so that it automatically connects. So essentially what we want to say here is, for each borough, count the number of primes. So what I'm going to do is I'm going to look at what's coming into our summarize tool, and we can see that the borough name is coming up as the field name. If we go up to our configuration pane, we can see name up here as a string. So what I want to do is count the number of primes per borough. So we're going to group this summarize on borough. So click on the name up here, and then go down to the add function here. Click the drop down arrow and group by. So click group by. Great. Now, if we remember, each prime had a specific ID, a unique ID. So to count the number of primes, we're just going to count these. So go up to our list again, click prime ID, and then go down to add, click the drop down arrow, and click count. I also wanted to have that map again, the map that was like the Met dashboard map. So for this, we're going to need to output the polygons of the boroughs. So that's the spatial object field. So we want to click on the spatial object field here, go down to add, click our drop down arrow, and go down to first. Now, yeah, we have a few less options than before because this is a different type of field. We don't want to count these, but between first and last, it doesn't really matter because each borough only has one polygon attached to it. If it had more than one, then it would change things a little bit, but we only have one, so it doesn't matter between first and last. So for this purpose, I'm just going to click first. Now, let's get a browse tool, because to see any of this spatial data, we need to have a browse at the end. So let's go up to our in-out tab, click on that, click and drag a browse on the end next to our summarize tool. And then we just want to run that. So go over to the top and hit run. Might take a little while. So I'll just give everyone a minute or so for the flow to run. In the operations, no, I don't believe it matters the sequence of the fields checking. So you should, so however you put those in order, you should still get the same thing because we're grouping the count by the borough and we're just outputting the spatial object. It might make a difference. I would think it would make a difference on how the fields come out of the tool, so which order the fields are in, but I don't believe it would make a difference in your answer. So this is what we have here. This is what we wanted. We wanted London Boroughs map with the count attached to it. So if you click on a borough in the table below in the results pane, you should see it highlighted. Also, if you click on a count, it should also highlight the borough that this is applicable to. Now, what I really want to do is have these in order from highest to lowest. So highest number of primes at the top and lowest number of primes at the bottom. We can do this in Alteryx with a sort tool. So this lives up in the preparation tab of Alteryx. So if we click on the preparation tab, it should be one of your first tabs. Now I want to go across to the sort tool and drag this on. Drag it between our summarize tool and our browse tool. So what I want to order here is the count. So it gives me two things to choose on our configuration pane. We've got name and we've got order. So the name is the name of the field that we want to order by. So let's pick counts there. And let's choose order as descending instead of ascending. So that's great. Let's go over and run our workflow. And I've just clicked on the browse tool. Yeah. So yeah, we can see the output of the sort tool is the count of primes in order, and we can see that their boroughs are attached. So Westminster here has the highest number of primes with 5,191 primes. If we scroll down to the bottom, we should have City of London with the lowest number of primes, and that's only 60. I think we're still having some sound issues, so hopefully you can hear me. Please do leave a comment on the chat. I'm not sure why this is, and I apologise for if you're getting any. So this gives us just a good overview of the London boroughs. We can see crimes per borough, and yeah, this is a nice overview of crime within London. But this doesn't really give us any specifics. We don't really have any local data. So what I want to do for the next one is create a more localized view of crime in London. And I'm going to be focusing on where I am here today at the information lab and finding out what sort of crime happens in the surrounding area and how close the nearest crime is. So I'm going to open a new workflow and I'm going to get up our data folder. And I'm going to go back to the crime folder. So I'll just give everyone a couple of seconds to do that. So, so if you've got your data folder open, all that I want to do is I want to drag our crime data in like we did before. So click and drag the file onto our canvas in Alteryx and drop that in. So I'm just going to go down and open the folder again. And I've actually created a little data source called address the data school. So that's the other file I want to bring in for this today. So let's click on that and just drag it in like we did the boroughs above the crime data. Now this only has one sheet, so you can just select the first sheet, sheet 1, and then go down and click OK. So let's run that workflow now, just with the 2 data sources as it is. Wonderful. So we can see on our results pane. Our crime data is what we're expecting. We've seen it before. We know the structure of that. We know there is no spatial elements in this file. So let's click on the output anchor of our address data. So yeah, this is the same. All this has is the name of the building, the street address, and the latitude and longitude points. So if I want to find out which crimes happen closest to the information lab, the data school, then what I need to do is create spatial points for both files, as there is none in either. So again, we need to use our create points tool for this. So let's go up to our spatial tab again, click spatial, and then go and drag on one create points tool, click and drag to next to our data school address and drop that in. That's picked up the longitude and latitude fine, and the fields are lat long floating points. So that's great. Now we want to grab another create points tool. So click and drag this on next to our crime data and drop it in close proximity. Wonderful. And we know these pick up the same latitude and longitude, and these are lat long floating points. So all the configuration is fine for this. I'm just going to go up to the in-out tab now. And then I want to drop a browse tool next to our point for the data school address. So click on the browse and drag it next to our create points tool for the data school address at the top. So let's run this workflow. So click run. And that's great. So it's created our point, the centroid point from our latitude and longitude. And this looks right to be, this is where I am today. So that's perfect. That is what I wanted to happen. So what I want to do next is I want to create a radius, essentially, to see how many crimes happen within 1 mile of the data school, to find our nearest crimes. So let's go up to the Spatial tab, and we're going to use a new tool. We're going to use Trade Area. So that's my last tool on the toolbar. So click on Trade Area and drag it next to our Create Points tool, next to the data school address, because we want to create a radius around that 1 point. So let's configure this now on our configuration pane on the left. The spatial object field point of point source is our centroid. That's the centroid we created, the data school point. And in the radius, we want to change the specific value to 1, because I'm only really interested in crimes that happen within 1 mile of our address. I'm going to keep the units to miles. And so the rest is good. We don't need to make any more changes. So let's go over to the Run button and click that. And then let's click on our Browse tool here. As we can see in our results pane, another spatial object has been created. That's our object trade area, our polygon. And we can see on our map that we have the mile radius around this point. So that is great. So our next step now is to match our crime points to that 1 mile radius. So I want all the points that happen within that circle we can see on the map. So I want to get our spatial match tool, again, that we're familiar with. And I want to drag this onto the canvas. Just drag it underneath the browse that we've got on the data school address, and don't let this connect up to anything again.
In what situation would you check eliminate overlap? That's true.
So what we're going to do is we're going to map this tool again. So what we want to do is, again, the data school address is that's what we know. We know this point and the area. What we don't know is which points are going to fall into the radius. So our target is our radius, and our crime points are our universe. But actually before that, because we're using a lot of different spatial objects, it might be useful for us to rename some of these. So I think it would be a good idea to add in a couple of select tools. So let's go up to our preparation pane at the top and click preparation, and then go across to our select tool. I want to drag and drop this in after our trade area and between our browse. Now, all I want to do here is I want to rename the spatial object trade area to something a bit more usable that we're going to remember. So I'm just going to call it DS trade area. I'm also going to rename our crime points. So let's get another select tool from the preparation pane and drag this on next to our create points tool. Mine's already connecting up to the target, but we don't want that. So I'm just going to right click on this connection and delete the connection. So I'm going to click on the select tool again, and I'm just going to change the centroid field to rename it in this field here as crime points. So let's all do that now. So let's run this workflow just to see those changes. Run. Well, I'm just getting an error because we haven't mapped the spatial match. That's fine at this stage. We don't need, we can change that in a second. So let's click on the output anchor of our bottom select tool and scroll through. And we can see that our crime points, our Centroid field has been renamed. So this just makes our data a bit more usable and user-friendly, especially as we're going to be using a few different spatial fields in this exercise. So let's go back to our spatial match tool. Now, as I said before, the data school is, the radius around the data school is our known point. So let's take the output anchor from the top select tool on our data school address workflow and drag the output anchor to the T input. Drop that in there. And let's also, while we're at it, take the output anchor from the bottom select tool, the crime data, and drag that up and connect it to the U input here. So this is why I changed some of the fields, because we get a few different options here because we have more than one spatial object in our files. So our target this time is the data school trade area because we want to know the different points that are within that area. So let's go click on the down arrow next to the spatial object field in the T input section and click on DS trade area or whatever it is that you've named this to. So our universe field, that's picking up the object field crime points. So that works in this instance, that's fine. We don't need to map anything else here. So I'm just going to run that now, go over to get rid of this error. And we click on our match tool, matched output here. And we can see that all these crimes have been mapped to the address. So this is everything that fits into our trade area polygon, which is exactly what we wanted. So now I want to essentially count which crime types are most common within this area. So what we can do is we can use a summarize tool again for this. So I want to go up to our transform tab and click and drag a summarize tool again to our matched output. So just drop that on. Now let's look at our input for this tool. So go on to our results pane and I want to have a look and see what crime name comes under. So yeah, we've got a field here called crime type. So we want to count the number of crimes that happen in this area per crime type. So we'll go up to our configuration pane for the summarize tool on the left-hand side. And let's scroll down in our options in the configuration pane until we get to crime type. It should be nearer the bottom. So once you've found crime type, click on that. And we want to make sure our data is grouped by this. So we'll go down to add and click group by. Now what I want to do is count the crimes. So as we know from our last exercise, each crime is uniquely identified by the crime ID. So let's go up and find crime ID in our configuration pane. I want to click crime ID here and go down to add and count these. I'm also going to output the spatial object for the trade area. So go up to DS trade area, or whatever you name that to, that should be near the top. Click that and go to add, and we'll just output that as first as well. So let's go to in out at the top and just add in a browse so we can see this properly. Click in out and click on the browse and drag this to the end of the summarize tool and hit run. So great, we've got our list of the most common crimes that happen in the area around the data school, the information lab, which is great. So let's go about sorting these again like we did before. Let's go up to our preparation tab at the top and let's click sort. Click and drag this in next to our summarize tool. And I want to go to our configuration pane now and click count as our name. And like we did before, the order is descending. And then go over and click run. So I'll give a moment for everyone's to run. And once it's run, just click the browse tool. So what we can see here is the most common crime around where I am today is just theft. Other theft and theft from a person are really at the top here. And possession of weapons is at the bottom with only 3 crimes counted. So we can also work with this to find the nearest crime to the data school and find out exactly how far away that was. And I want to look at that in meters. So we're going to use a different tool now. So let's go up to our spatial tab again. Click on our spatial tab. And the tool we want for this is we want the find nearest tool. So go across to our find nearest tool, click and drag that onto our canvas, quite away from everything else, just so it doesn't connect automatically. Drop that in. So as we can see, like our spatial match tool, we've got 2 inputs and 2 outputs. So here, again, our known point is the address of the data school, and our unknown points are those crime points, because we don't know which one is going to be the closest. So what I want to do is, we're actually not interested in the trade area for this particular point. We just want the address of the data school. So I'm going to go right back to the first create points tool we used, next to the address of the data school. And I want to click the output anchor, the little green arrow of that tool. So click this and drag this to the target. And it's picked up our centroid here, which is perfect. Now I'm going to use the output of the match tool for the universe, because that contains all our crime points within the 1 mile radius. And that is all we really need. We don't need all the other crime points because we know these aren't going to be the closest. So click on the M output of the spatial match tool and drag this up to the U input of the find nearest tool. Let's go to our configuration pane here and configure the universe. The spatial object field is not the centroid this time. What we want to map this to is the crime points. So this is where renaming the fields does become useful. So go down to where it says crime points or whatever you named your crime points to and click that. And we want to find the nearest number of points. We want to just find one of those, so that's fine for our purposes. We don't need to reconfigure this. The maximum distance, we can just set it to 1 mile because we know that's our radius size. So let's go over and click run. If we click on our matched output, we should only have 1 record. Now this is the closest crime to the data school. So if we see here, we've got the address of the data school, and if we scroll through our results pane, we've also got information about the crime. So scroll through and we can see, probably no surprise, that the crime is other theft. We've also got outputted our find nearest rank. So if we chose to find more than 1 point, it would rank them by the furthest and the nearest. We've also got a distance outputted in miles. So that gives us how far away it was from the data school. Now, I said we wanted to find this distance in meters, and we could convert this, but I want to be lazy and also show you how to use another tool. So for this, we can use our distance tool. So let's go to the top of our toolbar and go onto our spatial tab and click and drag the distance tool to our matched outcome here and just let it connect. So let's go to our configuration pane and configure this for our purposes. So the source point is correct, that's the centroid. And the destination point is actually our crime points. Now everything else looks correct, apart from we want to output the units in meters. So choose meters on the units, and we can go over and run this workflow now. So if we click our output anchor for the distance tool and scroll through our results pane, we can see the distance for the closest crime, the closest theft that happens to the data school is 191 meters, 0.4. So that's everything that we've really got time for today. I hope that you learned something, and I hope this was useful for you and introduced you to the possibilities of spatial tools in Alteryx. If you want to continue learning, I'd recommend that you follow us on Meetup if you don't already, and this has more information about other webinars, events, and training. For resources, I recommend utilising the Data School and the Information Lab blogs. These have a variety of different blog posts on Tableau and Alteryx, and definitely help me through when I'm working on things that I'm struggling with. And finally, to practice your skills, I really recommend utilising the Alteryx weekly challenges. There are several which focus on spatial data, and if you search for these on Google, then you shouldn't have trouble finding these. So thanks again. Thanks for tuning in, and yeah, I hope you found this beneficial. Have a really great day.